Assalamualaikum and hi everyone, welcome back to my channel. So kita akan teruskan sesi revision kita kali ini. Anda tak tahu mana nak mula? Jom kita mula dari sini. Okay, so now we are going to discuss chapter 4. It's about forces and free body diagram. Okay, so before we start, so let's review what is the type of forces that involved in this chapter. So the first force is frictional force or friction, and the symbol is small f. The frictional force is a contact force that act to oppose sliding motion between the surface. Okay, and always remember that the direction of the frictional force is always opposite direction with the motion. Alright, so for the second force is the normal force. So let's say we have a table or surface and we put an object on the surface. So there is a normal force that exerted by a surface on the object. Okay, and the normal force must be perpendicular to the surface. Alright, so this is the friction. Let's say the object is moving to the right. So look at here, the frictional force must be opposite direction. So the motion of the block, okay, that way. Okay, for the second one, so let's say we have two hanging blocks, A and B. Okay, so we're going to have tension. Okay, bila masa tension ni ada, okay, when the pull exerted by a string or rope or cable, okay, when attached to a body, okay, and the direction of tension must be always away from the object. Okay, mesti keluar macam ini. Okay, and applied force ataupun external force. Okay, so if you look at to the first diagram here, so we have the external force. We try to, let's say we try to push the object to the right. So the external force should be to the right and the motion also to the right. But the frictional force must be opposite direction. And the last one is weight. And the direction of weight must be always downward direction. Okay, straight down toward the center of the earth. Okay, so let's review about Newton's first law, where the law state that an object in motion will stay in motion in a straight line unless acted upon by unbalanced force, ataupun sekiranya ada force luar yang kita letakkan pada objek tu, dia tak bolehlah stay in a motion of a straight line motion, or a push or pull will cause object to speed up, slow down or change direction. Okay, so the Newton's first law state that the object will stay in motion or will stay in a stationary state unless there is external force that exerted on the object. Okay, so let's try to review. Forces are balanced, okay, means that the total force in X or total force in Y component is equal to 0 if the object at rest, okay, because V is equal to 0, so acceleration is also equal to 0. So maknanya dia stay at rest lah, tidak bergerak. Or the objects in motion, okay, means that the object is moving, the velocity is not equal to 0 now, but why A is equal to 0? Because the object is moving, but moving with constant velocity. Okay, when constant velocity, acceleration is equal to 0. Okay, so basically object just keep on doing whatever they are doing unless they are acted upon by an unbalanced force. Okay, so maknanya kalau objek tu tidak bergerak, so dia tidak bergerak lah. Okay, dia stay at rest, so A is equal to 0, the balance. Ataupun the object yang sedang bergerak with a constant velocity. Okay, so dia akan keep on moving with a constant velocity. That's why the acceleration is equal to 0. Okay, so now equilibrium, so at rest and moving at constant velocity. Ada dua keadaan. Equilibrium di mana at rest, where V is equal to 0 tadi, Okay, when V is equal to 0, A is equal to 0. So F net is equal to MA. So when A is equal to 0, dia tidak bergerak. So F net is equal to 0. Ataupun moving at constant velocity, A is equal to 0. Ingat, moving at constant velocity, A is equal to 0. That's why the total force or F net is equal to MA and it's equal to 0. Okay, object is moving with an acceleration, so object is accelerating. But with constant velocity, the acceleration is equal to 0. Okay, keadaan ini bila kita ada dua objek yang bergerak, tengok sama ada dia bergerak with constant velocity, A is equal to 0, ataupun dia accelerating with magnitude of berapa acceleration dia. So if the object is moving with an acceleration, so F net is equal to MA. But if the object is moving with constant velocity, F net is equal to 0. Okay, let's look at the steps to draw a free body diagram. First, make a sketch. Make sure you sketch first all the forces acting on the mass. For example, we have a block and we put an external force on the block and the block will move to the right. Okay, so when we sketch all the forces on the block, we have normal, friction, wake, and external force F. Okay. Okay, so for the second step, we need to draw a dot to represent the center of mass. Then we need to establish the x-axis along the plane where positive is the direction of the acceleration. Maksudnya adalah bila kita buat x-axis, kalau objek tu bergerak ke kiri, so A dia akan ke kiri. So kiri akan jadi positif. Bila objek tu bergerak ke kanan, so A ke kanan. So all the forces that directed to the right, okay, yang sama direction dengan A tadi akan jadi positif. Okay, so look at here. We have x and y component here. So x-axis must be always parallel to the surface and y-axis must be always perpendicular to the surface. We put a dot here to represent the center of mass. Okay, and now we need to draw force vectors in the proper direction pointing away from the dot. Okay, tails at the dot. Okay, so acceleration is to the right. Okay, look at here. The tail must be at the dot and the direction must be pointing away from the dot. So direction of wake here, downward, normal is upward, and frictional force must be opposite direction with the acceleration here. And this is the external force. Okay, ataupun applied force. Okay. And the last one, resolve any forces that are not directed along x or y axis into x or y components. So dalam case ni, semuanya berada pada x and y axis. So no need to resolve any force. Okay. So kalau yang ada angle, kita kena resolve. Kejap lagi kita tengok. Okay, next. Okay, so now look at the first example. Okay, we have a box of books, okay, where the weight is 319 Newton. Okay, is shoved across the floor by a force of 485 Newton exerted downward at an angle of 35 degree. Maknanya kita ada satu external force, okay, yang tolak box tu ke bawah but at angle of 35 degree. So yes. Okay, look at here. We have the external force 485 Newton that try to push the box, but the force is at an angle of 35 degree below the horizontal. Ini bawah. This is the horizontal, so below the horizontal. Okay. So given that mu k is 0.57, calculate the acceleration of the box. So first of all, let's try to draw the free body diagram first. Okay. So kalau kita tolak ke bawah, logiknya dia akan gerak ke kanan lah. Betul? So we put a small arrow here to represent the direction of the motion. Okay. And then let's draw x-axis, y-axis. Okay. So now look at here. Okay, look at the arrow, the blue color. The external force is in this direction. Okay, where here is the angle is 35 degree. Okay, and look at to the arrow. So for the free body diagram, make sure the arrow, okay, the force vector always pointing away from the dot. Always pointing away from the dot. So, arrow yang biru ini kita pindahkan dia. Okay, tengok. Saya pindahkan dia ke bawah. Okay. So, we still have the same direction, which is at angle of 35 degree. But now, the arrow must be pointing away from the dot. Okay. Then, we're gonna have, macam biasalah, kita ada normal force. Kita ada frictional force. Where the direction of the frictional force, remember, must be always opposite direction with the acceleration. And then we have weight, which is directed downward. Okay? So, the last one, we must resolve F into X and Y components before proceed to calculation. How we want to resolve? So, we have F in this direction. Okay? And from the tail, for the x component, so it should be to the right. So fx, f cos theta, and fy is downward, f sin theta. Okay, so for downward direction, we take it as negative direction. Okay, so we need to resolve first what is fx and fy before we proceed to the calculation. Okay, so now let's practice the second example. We have a 2 kg block slides down a rough ramp that is inclined at 30 degree to the horizontal. So this is the angle of the inclined ramp. Draw the free body diagram of the block. Okay, so as usual, look at here. I have the dotted blue line here, okay, which represents the x-axis. Remember that x-axis must be always parallel to the surface. So this is the surface of the inclined ramp. Okay, and this is y component. Y-axis must be perpendicular to the surface. Okay, so the direction is downward direction. Okay, sebab dia akan bergerak ke bawah lah, slides down. Okay, so we're gonna have normal. Normal mesti 90 degree to the surface. And we're going to have frictional force, where the frictional force must be opposite direction with the acceleration. Okay, and the last one, look at here. We have W, where W is straightly directed downward, ke bawah terus. Okay, kalau tengok base di sini, dia mesti 90 degree to the base here. Okay, and if here is 30 degree, and here is 90 degree, here should be, this angle should be 60 degree. So kalau sini 60 degree, sini pun akan jadi 60 degree, and this is 90 degree, and here is 30 degree. Dia akan sama dengan kat tepi ni. Okay, remember? Okay, 30 degree here and 30 degree here. Okay. So, look at to the free body diagram. We put the mass as a dot here, and we have normal, we have frictional force. So, look at here. That the arrow of the weight is at 4th quadrant. Okay, here. So you can imagine if we rotate this free body diagram here, and it will become like this. So W is equal to mg, and the angle should be here. Jangan salah, jangan letak angle dekat sini pula. So the angle here 30 degree. Okay, so again, we need to resolve W into X and Y components before proceed to calculation. So we're going to have WX, which is W sin 30. Okay, remember, line yang jauh daripada angle mesti sin. Line yang dekat dengan angle mesti cos. So WX, sorry, this should be WY. Okay, so this should be WY is equal to negative W cos 30. Okay, next. Alright, look at the third example. Let's try to draw the free body diagram for this example. Okay, we have a block where the weight of the block is given 100 Newton and it's on a rough plane. and the plane is inclined at 35 degree to the horizontal. Look at here, we have the angle of 35 degree and the block is in equilibrium. So equilibrium means that the object is not moving. Okay, so now so the question state that the block is in equilibrium. So remember that equilibrium means that the total force in x and y components is equal to 0. Okay, so why the block is in equilibrium? Because we have the horizontal force here. Kalau tak ada 40 Newton force ni, apa berlaku? This object maybe will sliding downward in this direction. Dia akan bergerak ke bawah. Okay, so because of the 40 Newton force that acting on the object, so now the object is in equilibrium. So we want to draw the free body diagram. So as usual, okay, kenapa friction ke sini? Okay, remember, try to imagine. Kalau tak ada external force here, what happen to the block? Dia akan bergerak ke bawah. Okay, dia akan perlahan-lahan jatuh ke bawah, moving downward, slide downward. Okay, so the direction of the frictional force must be opposite direction. Lagi kita ada apa lagi? Normal and wake. Okay, so first put the x-axis. Remember, x-axis must be always parallel to the surface, and we're going to have y-axis which is perpendicular to the surface. And remember, wake 35 degree here and 35 degrees here. Okay, normal must be perpendicular to the surface. And now look at to the external force. Okay, the direction of the external force 40 Newton here is parallel to the base of the plane. Base dia ini. Okay, bukan parallel to the surface. Ramai yang careless dan keliru. Where we want to put the external force F equal to 40 Newton here into our free body diagram. Alright, so now let's look at here. Okay, we have F. Okay, remember the direction of F here, and F 40 Newton is parallel to the base, while x-axis here is parallel to the surface. So now if this is 35 degree, okay, this should be equal to 35 degree. Okay, this should be equal to 35 degree. Okay, so ini adalah sudut berselang-seli kan, you belajar. Okay, saya ulang lagi sekali. The base of the plane is parallel to the external force F, and this is the x-axis which is parallel to the surface. Now 35 degree here, and this should be 35 degree here. Okay, so look at here. This is direction of the force F. And now let's try to rotate the axis. Okay, so this is 35 degree and we try to rotate the x-axis. Yes, in this direction. And we have y-axis. And we're going to have the dot represents the center of the mass. We have wick in the third quadrant. We have a normal force which is perpendicular to the surface. And we have the frictional force which is opposite direction to the motion. So the motion is to the left and the frictional force should be to the right. Okay, so now look at here, we have F here. Okay, sama macam sebelum ni. Okay, make sure all the vectors must be outward from the center. Semua direction arrow ni mesti tail dia kat sini, tak boleh head dia dekat sini. Okay, so kita pindahkan. Okay, tengok sini, kita pindahkan external force kita ke sini. Okay, that's all. Okay, so now this is 40 Newton here. Okay, you can see tadi kita pindahkan daripada sini jadi ini. So ramai yang confused lah. Okay, kalau soalan bagi macam ini, sebenarnya dia bukan parallel to the surface of the inclined plane. It's parallel to the base of the inclined plane. So awak lukis macam ni, parallel dengan ini bawah. So buat satu lagi line which is x component that is parallel to the surface of the inclined plane. So kalau sini 35, sini automatically akan 35 sebab ini adalah sudut berselang-seli. Okay, so saya ulang lagi sekali. Okay, so this is the original direction of the F. F tadi horizontal force. Okay, and it's 35 degree to the X component. Okay, to the X axis. So, kita rotatekan saja. Okay, awak rotatekan saja. So, dia akan jadi begini. Okay, let's do the calculation. Okay, so let's start example number 1. So, actually, this is from the previous example of free body diagram. So, we have a box of books weighing 319 Newton is shoved across the floor by a force of 485 Newton exerted downward at an angle of 35 degree below the horizontal. So we have looked at the free body diagram before. So we have the free body diagram like this. So we have transferred the direction of the arrow of 485 Newton force. Okay, and then we need to resolve the direction into X and Y components. Okay, so let's say we have, so here I write as Fx, which is F cos 35, and here we have Fy, which is negative Fy, which is negative F sine 35 degree. Okay, so now when we have this type of problems, so we need to write two equations, which is in terms of X and in terms of Y. So now look at to the free body diagram. We know that the object will move in X direction. So there is an acceleration which is to the right. Okay, sebab kita tolak dia tadi. So now the total Fx should be equal to ma or total to 0. So because we want to find the acceleration, so total Fx is equal to ma because the object is moving in X component, but Y is equal to 0. Okay, so when you start to answer this question, please write these two equations. Okay, so now total force in X component, so we look at in X components, so we have Fx minus friction. Okay, so we just have two forces here, which are Fx and friction. Okay, so we write as Fx minus friction is equal to ma. Alright, so as we know that Fx is F cos 35, so F cos 35 minus mu kn, remember friction is equal to mu kn, is equal to ma. Alright, so when we rearrange this equation, so we're going to have A is equal to F cos 35 minus mu kn over m. Okay, so now look at all the unknown. So we have this value F, mu k, m, but we don't have n, the normal force. So look at to the position of the normal force. Okay, dia duduk dekat mana? So normal force is on Y components. Alright, so we need to move to total force in Y components is equal to 0. Okay, so let's write as I want to use this color. Okay, so we write as total Fy, where we have n Fy and weight. Alright, so I will write, okay, so this is actually n plus negative F sine 35 plus negative W is equal to 0. Alright, therefore n is equal to F sine 35 plus W. Alright, so now let's write F is equal to 485 sine 35 plus M is the mass, so the mass is given. So no, it's not given the mass, it's given the weight of the book. Alright, it is 319 Newton. So we can calculate the normal force N. Okay, so the answer is 597.18 Newton. So we can substitute in this equation. Alright, so we can solve for acceleration, where acceleration is equal to 485 cos 35 minus mu k is 0.57 and 597.18 over the mass is given as, so we don't have the mass, right? So we need to find the mass first. Okay, look at here, we don't have the mass here, but we can find the mass from the weight given. Weight is equal to mg. So therefore, mass is equal to 32.5 kg. So this is the mass. Okay, so we want to substitute in this equation 32.5. Alright, so let's proceed to the calculation. Then acceleration, okay, make sure you press your calculator carefully. Alright, so the answer is 1.75 meter per second squared. Okay, jangan salah unit. So we settle question number 1. Okay, question number 2. A 2 kg block slides down a rough ramp that is inclined at 30 degrees to the horizontal. So we have the inclined plane, okay, where the inclined angle is at 30 degrees to the horizontal. Draw the free body diagram. So we have done the free body diagram before. So now we want to calculate the coefficient of kinetic friction of the ramp surface if acceleration of the block when sliding down the ramp is 1.2 meter per second squared. Okay, so now it's given that the direction. Okay, so now let's sketch the direction of the motion. Okay, so the direction of the motion is here. Okay, so it's positive x direction. So I put as A. So now, as we know, the question gives us that acceleration is equal to 1.2. But before we start, let's try to resolve the weight component first. Okay, so as we know, this is 30 degree. Okay, so now I want to resolve W into Wx and Wy component. Okay, where Wx is equal to W sine 30, it's to the right, so positive. Wy, we take it as negative W cos 30 degree. Okay, so now let's write the equation. Okay, so before we start, so this is the friction. Okay, so as usual, let's write the total force in X component and the total force in Y component. Okay, as the object is moving in X direction with an acceleration of 1.2 meter per second, that means the X component should be equal to ma, but Y component is equal to 0. Okay, because the object is not moving in Y component. Okay, so based on the free body diagram, look at here. In X component, we have two forces here, which is Wx and friction. We don't have any external force, okay, that exerted on the object. Maknanya objek tu bergerak dengan berat dia sendiri, okay, because of the weight. Alright, so Wx is to the right, so friction is opposite direction. So now we write as Wx plus negative friction because opposite direction of the motion. Friction bertentangan dengan direction of acceleration. Okay, so Wx is equal to mg sine 30 minus friction is mu kn equal to ma. Okay, so we do have all the values here, mg, mu, ma, but we don't have the value of Newton force. Sorry, we don't have. Okay, we do have all the information here. We have value of mg, mu k, but we don't have n, ma. So we need to find what is the value of the normal force. So since the position of the normal force in y component, okay, so the position of the normal force in y component, so we need to find the normal force, okay, the magnitude of the normal force by using total force in y component. Okay, so total Fy is equal to 0. And look at to the free body diagram, we have two forces in y direction. N is upward, Wy is downward. Therefore, we're going to write N plus Wy is equal to 0. So since Wy, we have put the negative sign here because the direction is downward. So we need to substitute here. N plus negative W cos 30 equal to 0. Therefore, N is equal to mg cos 30. We can straightly calculate what is the value of N. So mass is 2 kg, 9.81 cos 30 degree. So it's equal to 16.99 Newton. Okay, so now I substitute the normal force from y components into this equation. Okay, so you want to calculate what is the coefficient of kinetic friction mu. So I want to rearrange the equation first. So mg sin 30 minus ma is equal to mu kn. So our objective here, we want to find what is mu k. Therefore, mu k is equal to mg sin 30 minus ma over n. Okay, so as we have calculated the value of n just now, so we can substitute n. So kita masukkan to 9.81 sin 30 minus 2, and the acceleration is given 1.2 over n is 16.99. Okay, therefore mu k is equal to 0.44. Okay, so this is for part A. Okay, and for part B, the questions asks us to find what is the acceleration when we replace 2 kg block tadi kepada 8 kg box. Sekiranya kita letak box yang baru di mana beratnya 8 kg, agaknya berapa dia akan gerak? Okay, so let's try to calculate. So in this problem, okay, remember that coefficient of the kinetic friction is the same value. So we have calculated that mu k is 0.44 since this is the same inclined plane or inclined surface. Okay, so mu k is still equal to 0.44. So now I want to find what is the acceleration of the 8 kg box. So the free body diagram still the same free body diagram. Kita hanya tukar saja mass dia kepada 8 kg. So total Fx is equal to ma. Since I want to find the acceleration, so saya akan letak total Fx equal to ma lah sebab dia bergerak in x component. And total Fy is equal to 0. Okay, so now look at to the free body diagram just now. We have Wx minus friction is equal to ma is n minus Wy is equal to 0, n is equal to mg sin 30. Okay, angle pun still sama because this is the object still on the same inclined surface. So mass saja bertukar daripada 2 kepada 8. Okay, so n is equal to 39.24 Newton. And for this one, Wx is equal to mg sin 30 minus mu kn equal to ma. So now we want to find a. We rearrange the equation. We have mg sin 30 minus mu kn over m. And mass now is 8, 9.81 sin 30 minus mu k is 0.44. and the mass is 8 kg. Therefore, the acceleration is equal to 2.75. Okay, so the answer is 2.75. So when we compare from the previous question, okay, before this the mass is 2 kg, the acceleration given is 1.2 meter per second. But when we increase the mass on the inclined plane to 8 kg mass, what happened to the acceleration? Okay, maknanya semakin berat kalau kita letak objek pada surface yang sama, logiknya dia akan bergerak dengan lebih laju. Okay, so we finish question number 2. Okay, so now let's proceed to question number 3. We have a block of weight 100 Newton is on a rough plane that is inclined at 35 degrees to the horizontal. Okay, so as we have discussed before, so we need to draw the free body diagram first before we start the calculation. So make sure, okay, you know how to draw all the forces on the object correctly. Alright, so the block is in equilibrium. So perkataan equilibrium means that the total force in x component is equal to 0 and the total force in y component also equal to 0. Okay, so with a horizontal force of 40 Newton acting on it as shown in the figure below. So we want to calculate the frictional force acting on the block. Alright, so if you look at to the diagram, okay, if you look at to the block, so we have 40 Newton. Okay, so macam mana gambarnya asalnya? Okay, macam ini kan? Sekejap. Okay, kita ada plane. Okay, so we have an external force. So let's say ini adalah tangan awak. Okay, you try to hold the motion of the block with an external force 40 Newton. Okay, ataupun you try to push. Awak tahan dengan satu jari contohnya. Okay, so sekarang kalau tak ada external force F ni, apa berlaku? The object will move in this direction kan? Okay, dia akan bergerak ke bawah. Macam tu A dia. So automatically we must put the direction of the frictional force must be opposite direction. Okay, kalau kita tak ada 40 Newton tu tahan blok tu, apa yang akan berlaku? Okay, the block will start to move downward. Okay, so frictional force must be opposite direction, okay, with the motion. So the motion is downward, so the frictional force must be opposite direction. Okay, so in this case now, the system here, the block is in equilibrium. Maknanya bila you tahan dengan external force 40 Newton, you try to hold the box from moving. That's why total Fx is equal to 0 and the total Fy is also equal to 0. Okay, so now we want to calculate what is the frictional force acting on the block. Okay, sebelum kita tulis, you need to resolve first. Okay, look at here, we have the external force F and the weight. So make sure you resolve into two components. Okay, so let's say we use orange color. Okay, so now we have, I put as Fy, where Fy is negative F sine 35. And we're going to have Fx, okay, where Fx is equal to F cos 35, okay. And now, how about W? So we're going to have Wy is downward and then Wx in this direction. So I will write the equation here. Wy is equal to negative W cos 35 and Wx is equal to W sine 35. Okay, so now when we try to solve the problem, we want to find the frictional force where the position of the frictional force is on x component. Okay, daripada x component, paksi x. So now refer to the x component, we have three forces here, which are Wx, Fx, and frictional force. So now let's write the equation. Okay, so we have Wx plus negative frictional force, which is opposite direction, and plus negative Fx, is equal to 0. So Wx is equal to so now look at here, we have Wx is W sine 35. So it's W sine 35 minus frictional force. We want to find the frictional force here. And minus Fx, where Fx is equal to F cos 35. So we have F cos 35. Is equal to 0. Alright, so now we can substitute the value of W, which 100 Newton, sine 35 minus frictional force minus F is the external force, 40 cos 35 equal to 0. Therefore, the frictional force is equal to 100 sine 35 minus 40 cos 35. Make sure you press the calculator carefully. So 100 sine 35 is equal to 57.36 minus 40 cos 35. So 40 cos 35 is 32.77. So automatically we have the frictional force is equal to 24.59 Newton. So this is the answer. Kita tak guna pun total Fy, sebab guna Fx saja dah boleh selesaikan, because soalan tanya the frictional force. Kalau soalan tanya what is the coefficient of friction, mu k, then kita perlu guna total Fy is equal to 0. Why? Because as we know, when we want to find coefficient of friction, mu kn, so we need to find this one, the normal force. Untuk cari mu k. Tapi soalan minta frictional force, so kita tak perlukan this equation. Kalau dia suruh cari mu k, then we need to find normal force from the y component. Finish question number 3. So now look at example number 4. So we have two blocks on the inclined plane now. Alright, so a 9 kg box move and accelerate down a 28-degree inclined plane. So given that the angle of the inclined plane is 28 degree, and this is M1, where M1 is given as 9 kg and M2, we don't have the value of M2 here. Alright, so the question gives us that M1 is moving with an acceleration of 1.2 meter per second squared. And if the coefficient of kinetic friction is given is 0.15. This one is the coefficient of kinetic friction between the surface of the inclined plane and the box of M1. What is the mass of the hanging block? Alright, so we have two free body diagram here because we have two objects. So let's sketch the free body diagram. Red color here. Saya suka letak direction of acceleration here. In order to guide me to write the correct equation of each masses. So now let's draw the free body diagram of M2, where the direction of tension must be upward. Remember, so we have T and W2 downward. So how about M1? So I'm going to draw the y-axis, which is perpendicular to the surface, and x-axis must be always parallel to the surface. So let's draw the free body diagram. So here, so here we have W1. And this is the direction of the tension, always outward from the object. Okay, and the object is moving in this direction, okay, ke bawah, downward. Okay, so make sure you draw the friction force is opposite direction with the motion A. A ke sana, ke kiri. Okay, and apa lagi kita ada? Alright, that's all. So now let's draw the free body diagram. Okay, so the free body diagram for mass 1 and free body diagram for mass 2. Untuk mass 2 saya rasa tak ada masalah. Senang saja. We gonna have tension and also W2. Okay, where the direction of A letak kecil saja kat sini. Alright. So now how about FBD1, free body diagram for the first mass? Okay, so draw the x-axis, y-axis. Okay, so this is x-axis and this is y-axis. Okay, so now let's put a dot represents the body. Okay, like this. So we gonna have T. Okay, tengok dekat sini ya. T berada pada x-axis. It's on x-axis. So saya letak T here. And how about W1? So W1 is in this direction at angle of 28 degree. Okay, and also frictional force. Okay, kita letak color lain lah, frictional force. So frictional force and the arrow of the acceleration, the motion should be in this direction. Okay, maknanya dia boleh bergerak turun ke bawah. Okay, because we have WX. So W1 ni nanti make sure you resolve into WY and WX. So because we have the WX in X direction, okay, berat dia terlalu besar, so dia akan menyebabkan objek tu sliding down. Okay, so let's try to resolve. I want to resolve W1X dan W1Y. So I want to resolve W1Y and this is W1X. Okay, so W1Y is downward, so negative W cos 28, and W1X is same direction. Okay, same direction with W1X is same direction with the motion. Okay, so it's equal to positive W sine 28. Okay, so now let's start to construct two equations of x and y components. So now we have total fx is equal to ma not equal to 0, because the question gives us that the box is moving with an acceleration of 1.2 meter per second squared, and total fy is equal to 0. Okay, alright, so this one should be for mass 1 and mass 2. Okay, so saya buat yang ini adalah untuk mass 1. Okay, mass 1. Okay, and mass 2 here I will put mass 2. Mass 2 hanya bergerak in y component sahaja. Okay, so here is mass 2. Okay, we don't have the equation total fx. Okay, kenapa? Sebab FBD tu mass 2 ni hanya bergerak ke atas saja. The direction of A is upward. So we gonna have total Fy is equal to MA. Okay, bukan equal to kosong sebab dia bergerak ke atas. So I put as M2A. Okay, and this one is F1A. M1A is referring to the first mass. Okay, so now look at to the free body diagram. Okay, so we have in X component for the first mass we have T, tension, frictional force, and Wx. Since the direction of Wx is the same direction with A, so it should be positive. Okay, so now we write as W1x plus, this one is the total, right? Okay, so plus negative friction plus, okay, negative t is equal to M1A. Okay, so W1X is W sin 28. Okay, so letak W is mg lah. So mg sin 28. So mg sin 28 minus the frictional force is mu kn minus t is equal to, so for here we have acceleration dah ada. Okay, so kita boleh masukkan lah. Ini saya terus nak gantikan mu k, soalan dah bagi 0.15, so we just substitute here. 0.15 N is the normal force minus tension is equal to M1 is given as 9 kg and the acceleration is 1.2. Okay, so now look at to the equation. So we need to find the normal force from the y component because we need to substitute here. Okay, we don't have the normal force, okay, and we don't have the tension because we want to find the tension here, and we have mg. So the normal force, remember the position of the normal force is on y component. Okay, ni saya terlupa nak letak ni. Okay, so saya tambah. Okay, and okay, so look at here, in y component we just have normal and W1y is downward. Alright, so total force in y component should be equal to N plus W1y, okay, is equal to 0, where W1y is equal to negative W cos 28 equal to 0. So N is equal to mg cos 28. So kita dah boleh kira dulu N kita berapa. Okay, so 9 times 9.81 cos 28, so normal force is equal to 77.96 Newton. Okay, so we can straightly substitute in order to find tension. Tension is equal to mg, okay, awak masukkan sajalah terus, mass is 9.81 sin 28 minus 0.15, N is 77.96. 77.96. Okay, minus 10.8. Okay, so tension is equal to 18.96. Okay, so can we find what is the mass of the hanging block? Yes. Okay, we can find by using equation from the second mass, which is total Fy equal to M2A. Okay, so now this is for the second mass. So look at here, we have T minus W2, bukan W2 minus T. Okay, why? Because the direction of the tension is the same direction with the motion. So T should be positive and W2 should be opposite direction, so it's become negative direction. Okay, so in y component should be T plus negative W2y equal to M2A. Alright, therefore T minus W2y is M2G equal to M2A. Okay, therefore we can this one we can factorize the mass because we want to find M2. Okay, T is equal to M2A plus G and M2 is equal to T over A plus G. So T tadi kita dah cari 18.96, we can just straightly substitute 18.96 over 1.2 is the acceleration. Okay, and plus 9.81. Alright, and finally M2 is equal to 1.72 kg. Okay, so this is the answer. See you in the next session. don't forget to like, share and subscribe channel Madam Fika Fiki. Jumpa lagi. Assalamualaikum dan selamat sejahtera.